Good morning, I'm Jonathan Butz with VMware. I want to have a quick conversation this morning about software-defined storage and its benefits to healthcare as an industry overall. So first, let's talk about some of the industry pressures affecting healthcare today. We're seeing a lot of revenue pressure across the board. Declining reimbursements are imminent. We saw some reduction in reimbursements in 2013, which is putting increasing pressure on organizations to control OpEx and putting a lot of focus on what it costs to run infrastructure. To that end as well, traditionally, CapEx has not been a challenge, but we're seeing a lot of focus on reducing CapEx as well, wherever possible. Software-defined storage addresses the OpEx and CapEx problem in a very profound and meaningful way. But first, let's talk a little bit about, and to the tune of 30 to 60%, and we'll talk a little bit about where that comes from. So let's start by talking a little bit about where we are today from an architecture perspective, so we can talk about our ability to leverage this new technology. We've been building in a host and SAN attached model since pretty much the beginning of our virtualization journey. The question we should ask ourselves, though, is why have we built our infrastructure this way, built around this monolithic storage structure? And the answer really comes down to risk. The fact is that in almost all cases, our individual virtual machines, our systems, are unique. And because we have a lot of applications that simply cannot be made redundant at the application level, we must make them available and resilient at the infrastructure layer. And that requires a substantial investment in the storage area network, which of course imposes a great deal of CapEx and a great deal of OpEx expense associated with building and maintaining this infrastructure. We're ignoring, for the time being, the fiber channel infrastructure, which is another large CapEx component of this infrastructure for the time being. But that is also addressed by this new architecture. So what are our options to move away from this? Well, without a change in thinking and some new infrastructure capabilities, we can't. So we think about what other software companies have done that have had the luxury of building an application platform from scratch. What have they done? What assumptions have they made, and what have they been able to deliver? They've built it on the assumption that individual nodes are disposable, and the application itself must be resilient. They've also built on the design concepts that the infrastructure and the application that runs on it must be able to scale in a linear fashion. So what if we could apply some of these same design principles? An individual node is disposable, and we must be able to scale in a linear fashion. Well, we've actually already done some of that in our current virtual infrastructure today. We've addressed the scaling component from a CPU and a memory perspective with our host-based model. Where we run into challenges is scaling and getting additional performance out of our storage area network, which generally scales in large capital steps, which our CIOs have told us causes them some pain. So what we've done here is we've applied some of those same design principles in software to address the storage challenge as well. And it basically comes down to leveraging a combination of fast flash drives and slower spinning disks in the individual hosts in a distributed fashion to present a logical storage volume on which our VMs can live that is redundant at the software layer. So we no longer need to make a large investment, and we no longer have to worry about the details of making our storage available. And as we scale, we're still able to scale in the traditional fashion. When we need more compute and memory, we can simply add another host. When we need more storage capacity, we can add more spinning disk. And as we need more performance, more IOPS, we can add more flash. Now this is a little simplified for illustration capabilities, but the concepts are valid. So in this way, we're able to realize quite a bit of savings because where the bulk of the cost in your traditional array from any vendor, it's a collection of spindles and flash volumes, some x86 compute, and some software to operate it and manage it. Now, if you look inside the spindles of any array from any manufacturer, you'll find they're off-the-shelf components, but they're heavily marked up. as part of being bundled in this monolithic storage structure. The x86 compute, likewise, is heavily marked up, and then you're paying for the software on top of that. In this model, you're buying the off-the-shelf components yourself. The x86 compute is already present in your current node architecture, and you're buying the software from VMware. Now, one of the questions that does come up is, what about space? Data center space is a commodity for many organizations. How does this address that? Because we're changing the model often from a dense compute blade-based architecture back to a more distributed rack-based architecture. And we've done the math with a number of customers and concluded that the space is more or less a wash. There's not substantially more space required to deliver an equivalent compute and storage capability using this model as with this. Another question that comes up is, what about resiliency? You know, if you're designing now I have to be able to tolerate host failure, and I have to be able to deal with the host failure not only from a compute and memory perspective, but also from a data resiliency perspective. And we address that simply by having all of the data associated with any individual workload written to 2 places by default, and we can write to more in policy on a per VM basis. So we're able to survive. We're able to deal with the survivability the same way we were able to deal with memory and compute. Today, we're able to address that from a storage perspective in this software-based model. So this, again, is a very, very compelling transformational opportunity for us in how we architect our data centers and how we're able to build and scale our infrastructure that addresses some very prescient OpEx and CapEx pressures in the healthcare industry today.